the third standard point. It's also very simple. Here we need to draw perpendicular bisectors. We need to draw a perpendicular through midpoint of the side. This is the midpoint. Through this midpoint we can draw a perpendicular. This is perpendicular and it is passing through the midpoint, so it bisects this side, so we can call it as perpendicular bisector. What is meant by perpendicular bisector? A perpendicular bisector is line which bisects the side perpendicularly. Okay, a perpendicular bisector is a line which bisects the side perpendicularly. Now it is midpoint, and through this we can draw this perpendicular, so it is also a perpendicular bisector. And through this line, its midpoint, and through this midpoint we can draw a line, a perpendicular. It is also a perpendicular bisector. These three perpendicular bisectors meet at one point. That point is nothing but point of concurrence, so that point can be called as circumcenter. By taking circumcenter as center and the distance between the circumcenter and the vertex is as radius, then we can construct a circle. That circle is nothing but circumcircle. In a triangle, the perpendicular bisectors are concurrent. Here the point of concurrence is circumcenter. It can be denoted as S. The circumcenter can be denoted as S. Okay. By taking S as center and SA is equals to SA is B, and this is SA is equals to SB is equals to SC as radius. Here SA and SB and SC are obviously equal. So by taking that measurement as radius, we can construct a circle. It is called circumcircle. It will be like this. A circumcircle touches all the vertices of the triangle. A circumcircle touches all three vertices of triangle. Okay, it is the concept of perpendicular bisectors. Now coming to the fourth standard point is angular bisectors concept. This is angle. We can bisect this angle into two equal parts. Then we can draw this line. This angle, we can bisect this angle into two equal parts. We can draw this line. And this is angle, we can bisect this angle into two equal parts. We can draw this line. So it is called the incenter. It can be denoted by I, A, B, C. Let it be D. Okay. In a triangle, the angular bisectors are concurrent. What's meant by angular bisector? Which bisects the angle. Angular bisectors. What is meant by angular bisectors? The line which bisects the angle. Here we have the following one. A, B, C are vertices. AD, some BE, some CF are the angular bisectors. Now the point of concurrence is nothing but incenter. We can call it as incenter. We can denote it with I. In a triangle, the angular bisectors are concurrent. The point of concurrence is incenter. By taking I as center, ID as shown in figure, as radius, we can construct a circle. It can be called as incircle. This is the concept of incircle. Now, up to now, we have learned GOSI. G means centroid. O means orthocenter. S means circumcenter. I means incenter. Up to now, we have learned these concepts. GOSI. G means centroid. Centroid is the point of concurrence of medians. Orthocenter is the point of concurrence of altitudes. Circumcenter is the point of concurrence of perpendicular bisectors. Incenter is the point of concurrence of angular bisectors. These are the concepts. Apart from these concepts, we have excenter also. This is a triangle. As we know, we can extend these sides. And then here is one angle, here is one angle, here is one angle. The angular bisector of one interior angle and the angular bisectors of two exterior angles forms the excenter, some I1. By taking I1 as center and I1D as radius, we can construct a circle. It is called an excircle. For a triangle, we can draw 3 excircles like this. we can extend these two. So here is one X circle, and we can extend these two, and then here we have another X circle. We can extend these two, so we can have another X circle. So this is I1 center of X circle, this is I2 center of X circle, this is I3 center of X circle. For a triangle we have 3 X centers, 3 X circles we can draw. This is the concept of X center. There is another concept is here, 9-point circle. 9-point circle. By taking 9 points, we can construct this. A, B, C are vertices. A dash is altitude, B dash is altitude, C dash is altitude, and the midpoint of, so this is called O. The midpoint of AO is something P, the midpoint of BO is something Q, the midpoint of CO is something R. One, two, 3, 4, 5, 6. Apart from these, we can take some other points like perpendicular bisectors. By taking the all 9 points, we can construct a triangle, or we can construct a circle. That circle is nothing but 9-point circle. This is the different concept here. We need to observe, we no need to observe this here, so we need to observe up to X center. Okay, now for an equilateral triangle, all the standard points coincide. For the equilateral triangle, all the standard points will coincide with each other. Coming to an isosceles triangle, for the isosceles triangle, all the standard points collinear. This is the concept behind the standard points. The remaining class we can continue tomorrow. Thank you.